In the desolate expanse of Chile's Atacama Desert, a robotic sentinel scoured the night sky for threats. The Atlas telescope in Rio Hurtado wasn't chasing cosmic wonders. It was hunting asteroids that could shatter our world. Yet, on a clear July night in 2025, it caught a faint glimmer slicing through the stars in Sagittarius. This was no ordinary rock tumbling in familiar orbits. It was charging against the cosmic tide, defying the orderly swirl of our solar system, where planets and comets dance predictably around the sun. Early data pegged its speed at a staggering 130,000 miles per hour, fast enough to cross America in under 2 minutes. Astronomers at the University of Hawaii, overseeing ATLAS, sensed something extraordinary. Archival images from June, pulled from other Atlas sites and the Zwicky Transient Facility, revealed it had been lurking, disguised among the stars. This intruder, soon named 3, I/ATLAS, carried the chill of deep space, ice forged in an alien star system, now stirring under our sun's distant warmth. What secrets did it hold? Why was it here, on a path so eerily precise? Brace yourselves. The cosmic chase begins. As global observatories locked onto the anomaly, its strangeness came into sharp focus. Its trajectory screamed outsider, a hyperbolic path with an eccentricity of 6.14, the highest ever recorded for such a visitor. Anything over 1 means it's not bound to our sun, just passing through, destined for the void. Oumuamua hit 1.2, Borisov 3.4, but this shattered records, hinting at a violent ejection from its home eons ago. Imagine a bullet fired from the galaxy's edge, aimed with uncanny precision. Entering from Sagittarius, near the Milky Way's ancient star fields, it suggested an age predating our solar system, perhaps 7 billion years. Its brightness hinted at a massive size, up to 7 miles across, dwarfing past interlopers. Unlike the silent Oumuamua, this one was alive, its fuzzy coma of gas and dust signaling active ices. Water vapor, maybe carbon compounds, teasing alien chemistry. Its speed, 36 miles per second, defied local physics, pointing to a cataclysmic birth, perhaps from a stellar collision or planetary slingshot. Could it be more than natural? Hold fast. The mystery deepens. The astronomical world erupted into a frenzy. Harvard's Avi Loeb, known for bold theories, sparked debate. What if 3I/ATLAS isn't just ice and rock? Its glow, its precise path skirting Venus, Mars, and Jupiter, and that impossible speed. Could it hint at alien engineering? Loeb's paper suggested a probe-like origin, challenging the comet label. Natural explanations stretch thin, he argued, urging open minds. Most scientists, though, saw a time capsule, its composition a window into alien planet formation. NASA's James Webb and Hubble captured teardrop shapes and jets, revealing dynamic activity. This was only the 3rd such visitor in history, a cosmic lottery win. With perihelion looming in October at one point, 4 astronomical units, time was short. Amateurs and pros alike tracked it as it grew brighter in backyard scopes. A routine scan had unveiled a galactic nomad, shattering our cosmic solitude. Is it a natural wanderer or something more? Ready yourselves. The truth awaits. Imagine a cosmic bullet piercing the void, hurtling toward our sun at speeds that shatter every record in the books. When astronomers crunched the numbers on 3I/ATLAS, jaws dropped across observatories worldwide. This interstellar comet isn't just fast. It's clocking 36 miles every single second, or 130,000 miles per hour. That's enough velocity to rocket from Earth to the Moon in under 2 minutes, or dash across the Atlantic in seconds flat. But this isn't about earthly races. It's a galactic sprint that defies the physics we thought governed space travelers. In our solar system, comets and asteroids mosey along at modest paces, bound by the sun's gravitational leash. Yet 3 IATLAS blasts through like it's late for a cosmic appointment, carrying excess energy that screams of an origin far beyond our stellar backyard. Early data from ATLAS telescopes in Chile and Hawaii painted a picture of pure hyperactivity, a velocity so extreme it guarantees escape from our sun's pull, no matter how close it swings. This hyperbolic speed isn't random. It's a fingerprint of catastrophe, hinting at a violent ejection from its home system, perhaps flung by a dying star or a planetary giant's gravitational whip. As scientists modeled its path, the implications hit like a meteor. We're witnessing a survivor of interstellar extremes, now rewriting the rulebook on how fast the universe delivers its messengers. Brace yourselves. The speed secrets accelerate. To grasp why 3 IATLAS's velocity stunned the scientific world, compare it to its interstellar siblings. The first visitor, Oumuamua, in 2017, zipped by at 16 miles per second. Impressive, but child's play next to this newcomer's 36. Then came 2 I Borisov in 2019, clocking 20 miles per second, still outpaced by our latest guest. This comet doesn't just beat records, it obliterates them, traveling nearly twice as fast as anything we've snagged from beyond our system. What makes this speed revolutionary? It's not mere bragging rights. It's a window into cosmic violence. In space, velocity tells tales of birth and exile. Slow wanderers might drift from gentle nudges, but 3 IATLAS's blistering pace demands epic forces, perhaps a supernova's shockwave, a black hole slingshot, or a stellar collision hurling debris across the galaxy. Harvard's Avi Loeb, ever the provocateur, whispers bolder ideas. Could such unnatural acceleration hint at artificial origins? Oumuamua's odd speed tweaks sparked his alien tech theories. Now 3 IATLAS amplifies them, its trajectory too precise, too energetic for mere nature. As Hubble and James Webb data rolled in, confirming the comet's core integrity despite eons of radiation battering, questions mounted. This isn't a lazy float through space. It's a high-stakes dash, preserving ancient ices that could spill secrets of alien worlds. Hold tight. The physics-defying puzzle intensifies. The true bombshell of 3 IATLAS's speed lies in what it reveals about the galaxy's hidden highways. At 58 kilometers per second, this comet crossed vast interstellar gulfs in mere millions of years, a blink in cosmic time, suggesting a relatively recent launch from a nearby stellar nursery. Backward tracking its path points to Sagittarius, a stellar hotspot where gravitational chaos could eject such speed demons. But here's the twist: sustaining that velocity through the void's hazards, cosmic rays sandblasting surfaces, dust impacts like micro-bullets, demands resilience that borders on the miraculous, or, as Loeb posits, engineered durability. His work on Oumuamua argued anomalies like non-gravitational boosts could signal solar sails or tech. Apply that to 3 IATLAS's record pace, and fears emerge. Is this a probe scouting our system? Mainstream astronomers counter with natural explanations, a red dwarf's flare or binary star tango providing the kick. Yet the energy math is mind-bending, equivalent to hurling a mountain at escape velocity. As perihelion nears in October 2025 at 1.4 astronomical units, this speed will fuel dramatic outbursts, vaporizing tons of material hourly. For scientists, it's a ticking clock, months to decode a velocity that could upend our understanding of interstellar traffic. Is it a natural nomad or something sentient? Prepare yourselves. The cosmic truths race ahead. Picture a cosmic detective story unfolding across billions of miles. When astronomers traced the path of 3I/ATLAS, they uncovered a truth that silenced observatories worldwide. This comet wasn't born in our solar system. Its orbit is a screaming declaration of alien origins, etched in the mathematics of the stars. Orbital eccentricity, the cosmic ID card, tells the tale. Anything under one loop around our sun, anything over, breaks free. 3I/ATLAS clocks a staggering 6.14, the most hyperbolic path ever seen, dwarfing Oumuamua's 1.2 and Borisov's 3.4. This isn't a visitor lingering for tea. It's a galactic nomad, blazing through on a one-way ticket to eternity. Its trajectory, slicing from Sagittarius, points to a birthplace among ancient stars, perhaps 7 billion years old. Unlike local comets, tethered to predictable orbits, this intruder follows an open curve, unbound by our sun's gravity. Early calculations from ATLAS and Zwicky data confirmed it. No planetary tug or solar pull could trap this speed demon. It entered our system like a spear thrown from another galaxy, carrying ice forged in alien fires. But why this path, so perfectly aligned for our telescopes to catch? Is it chance or something more? The math of 3I/ATLAS's orbit reads like a forensic report from the stars. Astronomers, acting as cosmic sleuths, ran its trajectory backward, rewinding millions of years through the galaxy's chaos. The result? A path tracing to the Milky Way's dense disk near Sagittarius, a star, our galaxy's heart. This comet didn't wander aimlessly. It threaded a needle through gravitational storms, dodging stars and black holes to reach us. Its eccentricity of 6.14 screams of a violent launch, perhaps a supernova's blast or a binary star's gravitational slingshot, hurling it across light years. Such precision demands extraordinary energy, far beyond what our solar system could muster. Supercomputers at MIT and ESA modeled its journey, accounting for every stellar nudge over eons. The verdict? 3I/ATLAS left its parent star long before humans existed, carrying pristine ices untouched by our sun. Yet, its route raises eyebrows. Why does it skirt Venus and Mars at perfect viewing angles? Harvard's Avi Loeb stirs the pot. Could such a path suggest design, a probe sent to graze our system? Most dismiss it, citing natural chaos, but the numbers tantalize. Each data point, from Hubble to ground scopes, locks in its interstellar truth. What launched this wanderer, and why now? Hold fast. The orbital enigma deepens. Confirming 3I/ATLAS as interstellar was like cracking a celestial code. Global observatories, from Chile's VLT to Hawaii's Keck, synchronized to map its every move. Each measurement, position, velocity, angle, built a case ironclad by science. The comet's path, entering at 36 miles per second, resists our sun's grasp, even at its closest pass of 1.4 astronomical units. No local object moves this way. Its orbit is a cosmic arrow shot from another star system. Backward projections pinpoint a launch millions of years ago, likely from a turbulent stellar nursery where massive planets or exploding stars flung debris into the void. The precision is staggering. A 1 inch per second error could misplace its origin by light years. Yet, its trajectory aligns too neatly with Earth's view, sparking whispers of intent. Loeb's team at Harvard fuels speculation. Could this be a beacon, not a comet? Mainstream science counters with gravitational chaos, but doubts linger. As 3I Atlas nears perihelion, its path offers a fleeting chance to decode its story before it vanishes forever. This is no mere rock. It's a galactic envoy challenging our place in the cosmos. Is it nature's fluke or a signal from the stars? Imagine standing before a cosmic titan, a wanderer so vast it dwarfs mountains. When astronomers sized up 3I Atlas, they uncovered a scale that stunned the scientific world. Early estimates pegged this interstellar comet at 6 to 12 miles across, a city-sized behemoth compared to its predecessors. Picture Oumuamua as a football field, 800 feet long, 2I Borisov, a city block. But 3I Atlas? It's an entire metropolis, sprawling across the void, carrying ice and rock, forged in an alien star's crucible. Unlike local comets, often mere miles wide, this giant's bulk suggests it survived a million-year gauntlet through interstellar space. Its surface, scarred by cosmic rays, hides a core of pristine material, a time capsule from a world we'll never see. Telescopes like Hubble and James Webb caught its glow, revealing a teardrop shape, a bright nucleus wrapped in a glowing coma of dust and gas stretching thousands of miles. This isn't just big. It's a structural marvel, enduring eons of radiation and micro-impacts that would shred lesser objects. How did it stay intact? Was it built to last by nature's chaos, or something more deliberate? The scale alone challenges our understanding of what crosses the stars. Brace yourselves. The giant's secrets loom large. Sizing up 3I Atlas was like measuring a ghost with starlight. Astronomers turned to light itself as their ruler, analyzing how much sunlight the comet reflected from billions of miles away. By comparing its brightness to its distance from Earth and the Sun, they estimated a nucleus 1 to 3 miles wide, surrounded by a coma vast enough to swallow planets. Hubble's sharpest images revealed a cosmic teardrop, its nucleus a blazing beacon within a haze of sublimating ice. Jets of gas and dust sprayed outward, hinting at a complex structure. Rocky layers mixed with frozen water and exotic compounds. This giant's resilience is key. Smaller objects erode to dust in the interstellar void, blasted by radiation and microscopic collisions. Yet 3I Atlas's bulk shielded its core, preserving alien chemistry from its birth system. Was it forged in a dense stellar nursery, where massive planets sculpted such giants? Or, as Harvard's Avi Loeb muses, could its durability suggest artificial design? A probe built to withstand cosmic trials. The coma's glow, laced with carbon and organics, teases stories of alien worlds. Each grain of dust is a clue, a fragment of a distant star's legacy. Why is it so large, so intact? Hold fast. The structure's mysteries unfold. The structure of 3I Atlas is a cosmic puzzle, pieced together by light and math. Hubble's lenses caught details no ground telescope could. A nucleus pulsing with activity, jets erupting like geysers from a city-sized core. This isn't a static rock. It's a dynamic world, shedding thousands of tons of material as solar heat awakens its ices. Its teardrop coma, stretching wider than Earth, reveals a layered interior, rocky debris, water ice, and hints of organic molecules, all preserved through a galactic odyssey. Such size and strength defy the odds. Interstellar space is a sandblaster, eroding most travelers to rubble. Yet this giant arrived robust, its core shielded by outer layers that took the brunt of cosmic punishment. Was it a freak of nature, born in a violent stellar clash? Or, as some whisper, a crafted vessel, its structure too perfect for chance? The scale suggests a cataclysmic origin, perhaps a supernova's debris or a planet's shattering kick. As it nears perihelion in October 2025, its outbursts grow, offering a fleeting glimpse into its makeup. Every jet, every dust grain is a postcard from an alien star, challenging us to decode its purpose. Is it merely a comet or something sent? Prepare yourselves, the cosmic giant speaks. Imagine finding a single grain of sand on a beach stretching across the galaxy. That's the staggering improbability of spotting 3, Ia Atlas, a cosmic wanderer from beyond our solar system. In all of human history, we've confirmed just 3 interstellar visitors, fewer than the number of people who've walked on the moon. The first, Oumuamua, shocked us in 2017. Borisov followed in 2019. Now, 3I Atlas, caught by a Chilean telescope in 2025, marks a third, a celestial lottery win. Our galaxy teems with 400 billion stars, each potentially flinging comets and asteroids into the void. Logic says interstellar travelers should swarm, yet spotting one is like catching a whisper in a cosmic storm. Most slip through our solar system unseen, too faint, too far, or lost in the glare of stars. 3I Atlas, blazing at 36 miles per second, was a fluke, its brightness and path aligning perfectly with Earth's watchful eyes. This rarity transforms it into a scientific treasure, a fleeting chance to study matter from an alien star. But why did we catch it now, in this precise moment? Is it mere luck, or a signal meant to be seen? The rarity of 3I Atlas isn't just about numbers, it's a cosmic gauntlet. Interstellar space is a vast, dark ocean, where objects drift unseen for millions of years. Detecting one demands perfect timing, cutting-edge tech, and a dash of fate. The Atlas network, designed to spot Earth-threatening asteroids, snagged this comet by chance, its glow standing out against the starry veil of Sagittarius. Unlike Oumuamua, a dim enigma that faded fast, or Borisov, a fleeting comet, 3I Atlas offers months of study, its coma flaring as it nears our sun. This window is precious. Interstellar visitors don't linger. They flash through, gone in years, leaving us scrambling for data. Each detection pushes our tech to the limit. Pan-STARRS caught Oumuamua, an amateur found Borisov, and now Atlas claims this giant. But for everyone we see, millions pass unnoticed, silent nomads in the void. Could 3I Atlas visibility be more than chance? Harvard's Avi Loeb wonders if its path, so ideal for observation, hints at intent. A beacon sent to catch our gaze. The odds of this moment spark questions. Is it nature's whim, or something orchestrated? Hold fast. The rarity's secrets unfold. Every glimpse of 3I Atlas is a scientific goldmine, a once-in-a-lifetime shot to touch the stars. Its detection required a global symphony, telescopes from Hawaii to Chile, amateurs to NASA, all racing to capture its light before it flees at 130,000 miles per hour. Unlike planets visible for centuries, this comet offers mere months before it vanishes into the cosmic abyss. Its size, up to 12 miles wide, and active jets make it a spectacle, but its rarity lies in what it carries: alien ice, dust, and perhaps answers to life's origins. Only 3 such objects in history, each a new continent in the cosmic sea. The math is humbling. Our solar system is a speck in the galaxy. Yet 3I Atlas found us, its path threading past planets for perfect viewing. Is this luck, or did something guide it here? Loeb's theories fuel speculation. A probe, not a comet, designed to be seen. Mainstream science sees a natural marvel, but the timing nags. Why now, when our tech can finally decode it? As perihelion looms in October 2025, this visitor's fleeting visit challenges us to act fast or lose its secrets forever. Is it a random gift or a cosmic call? Prepare yourselves. The void's rare messenger speaks. Imagine holding a vial of stardust from an alien world, its molecules whispering secrets of a distant star. As 3I by Atlas streaks toward our sun, its coma, a glowing shroud of gas and dust, spills chemical clues that electrify astronomers. Spectroscopes, the cosmic chemist's tools, dissect its light, revealing a molecular tapestry unlike anything born in our solar system. Water vapor dominates, proof it formed in a frigid realm where ice could crystallize. But there's more. Carbon monoxide, carbon dioxide, and traces of organic compounds, complex molecules hinting at processes mirroring Earth's early days. These aren't just chemicals. They are a cosmic diary, written in the language of atoms, from a star system perhaps billions of years older than ours. Detected by telescopes like Keck and the James Webb, these emissions are pristine, preserved in deep space's freezer for eons. Each puff of gas is a direct sample from an alien planet's cradle, carried across light years to our doorstep. Why does it carry such rich chemistry? Could these organics suggest life's building blocks? Or something engineered? The chemical portrait of 3I Atlas is like decoding an alien's DNA. As solar heat awakens its icy core, streams of gas and dust erupt, each molecule a clue to its birthplace. Spectroscopic data, gathered from observatories worldwide, reveals water isotopes with ratios unseen in our comets, pointing to formation in a colder, denser stellar nursery, perhaps near a red dwarf or a young star's chaotic disk. Carbon compounds, including methane and complex organics, suggest chemistry that could seed planets or even life. These molecules survived millions of years of cosmic radiation, shielded by the comet's massive core. Unlike Oumuamua, which stayed silent, or Borisov, with simpler emissions, 3I Atlas is a chemical exhibitionist shouting its story across the spectrum. Harvard's Avi Loeb raises an eyebrow. Could such pristine, complex organics hint at artificial synthesis, a payload from a distant civilization? Mainstream science sees a natural relic, but the clarity of these signals, untainted by our sun's influence, feels almost too perfect. Each grain of dust is a postcard from another star, begging the question, is this a random traveler or a deliberate delivery? Hold fast. The molecular mysteries deepen. Every molecule streaming from 3I Atlas is a cosmic artifact, a direct link to an alien star's past. As it nears perihelion in October 2025, its coma flares brighter, offering a chemical jackpot. Telescopes catch water, carbon monoxide, and organics in ratios that scream extraterrestrial origins, formed in conditions alien to our solar system. These compounds, preserved through a million-year trek, resist cosmic rays that should have cooked them into simpler forms. The comet's size, up to 12 miles wide, shielded its core, like a vault locking away a star's secrets. Spectroscopic spikes hint at rare isotopes, suggesting a birthplace near a massive star or supernova remnant. But the clarity of this chemical snapshot puzzles scientists. It's too pristine, almost curated. Loeb's speculation looms. Could this be a crafted archive, not just a comet? Critics argue it's nature's work, a relic from a planet-forming disk. Yet, as jets spray organic-rich dust, the possibility of life seeds, or even a signal, ignites debate. This fleeting visitor, visible for mere months, is a chemical time machine, challenging our cosmic solitude. Is it a natural fossil or a message from the stars? Prepare yourselves. The alien echoes resound. Picture a cosmic arrow threading a needle through the galaxy's chaos, hitting a bullseye billions of miles wide. The trajectory of 3I Atlas is no random wander. It's a masterclass in precision, slicing through our solar system with uncanny accuracy. Entering from Sagittarius, it skirts Venus, Mars, and Jupiter at distances ideal for Earth's telescopes, never dipping into solar glare. This path, mapped by observatories from Chile to Hawaii, feels almost choreographed, as if designed for us to see. Orbital mechanics don't deal in coincidences. Planets and stars tug at travelers, bending paths over eons. Yet, 3I Atlas follows a hyperbolic arc. Eccentricity 6.14, dodging gravitational traps that should have derailed it. Its speed, 36 miles per second, ensures escape, but its route maximizes observation time, peaking at perihelion in October 2025. Is this luck? Harvard's Avi Loeb dares to ask. Could this be a probe, its path engineered to graze our system? The odds of such alignment, passing close enough to dazzle yet far enough to avoid capture, are astronomical. Each data point from Hubble and James Webb sharpens the mystery. A comet or something sent? The trajectory of 3I Atlas reads like a cosmic script, too perfect to be mere chance. Its path, traced backward by supercomputers at ESA and MIT, points to a launch millions of years ago from a stellar nursery near the Milky Way's core. To reach us, it navigated a gravitational gauntlet, stars, black holes, and rogue planets, yet arrived on a route that threads between our planets like a dancer on a cosmic stage. At 1.4 astronomical units during perihelion, it will glow brightest, visible to amateur scopes worldwide, as if inviting scrutiny. This alignment baffles astronomers. Most interstellar objects pass undetected, lost in the void's vastness. Why does this one parade before our eyes? Loeb's theory stirs debate. A natural comet shouldn't pick such an ideal path. Could it be a beacon? Its trajectory a deliberate signal from an alien mind? Mainstream science counters with chaos theory, random gravitational nudges aligning by fluke. But the math strains belief. A 1-degree error eons ago would have sent it elsewhere. As telescopes track its every move, the question lingers. Is this path a cosmic accident or a crafted invitation? Hold fast. The design's secrets beckon. Every twist of 3I Atlas path is a cosmic riddle, daring us to question its purpose. Its trajectory, locked in by global observatories, is a marvel of geometry. Entering at 58 kilometers per second, it weaves past planets with precision that defies the galaxy's chaos. This isn't a drunken stumble through space. It's a calculated arc, offering months of clear views before vanishing post-perihelion. The odds of such a path align with Earth's observation window are staggering, like hitting a galactic jackpot. Loeb's bold hypothesis fuels whispers. Could this be an alien craft, its route programmed to catch our attention? Critics argue nature's randomness, stellar slingshots, or supernova kicks could explain it. Yet, the path's perfection nags. It avoids close planetary encounters that might deflect it, as if guided. As October 2025 nears, telescopes capture its growing coma, a spectacle tailored for study. This fleeting visitor, one of only 3 in history, challenges our cosmic solitude. Is it a natural wanderer, shaped by blind forces, or a signal meant for us? The data pours in, but the truth remains elusive. Picture a frozen giant, slumbering for millions of years in the icy void between stars, suddenly stirred by a distant star's warmth. As 3I Atlas nears our sun, a cosmic awakening begins, transforming this interstellar relic into a blazing comet. Locked in a deep freeze since its birth in an alien system, its ices, water, carbon monoxide, and exotic compounds have lain dormant, untouched by heat or light. Now, at 4 astronomical units, roughly the distance to Jupiter, solar radiation begins to tickle its surface. Like a time lapse of spring sweeping an alien world, the first molecules break free, escaping as wisps of gas. This isn't just melting, it's sublimation, where solid ice turns directly to vapor, carrying dust like leaves in a cosmic breeze. Telescopes worldwide, from Chile's FIFIV-LT to NASA's James Webb, catch the faint glow of a forming coma, a hazy veil stretching thousands of miles. This transformation marks 3I Atlas as alive, not a dead rock like Oumuamua, but a dynamic entity shedding its ancient skin. Why does it awaken so vividly now? Is it merely nature's response, or a designed reaction to our sun? The awakening of 3I Atlas is a celestial spectacle, a dance of physics on a planetary scale. As it closes to 3 astronomical units from the sun, solar energy intensifies, snapping molecular bonds in its icy core. Water ice, formed in a distant star's frigid embrace, vaporizes first, followed by volatile carbon compounds. These eruptions create jets, fountain-like sprays visible even in small telescopes, marking active regions on its city-sized nucleus. Each jet spews thousands of tons of material daily, building a coma that could engulf Earth. Unlike local comets, this interloper carries alien ices, preserved through eons of cosmic radiation. Its resilience puzzles scientists. How did it shield such volatile compounds across light years? The coma's glow, rich with organic molecules, hints at a chemistry that could seed life. Harvard's Avi Loeb muses, could this outburst be more than natural, a mechanism triggered by design? Mainstream astronomers see a comet reacting to heat, but the intensity feels almost theatrical, as if meant to dazzle. As dust and gas stream away, they paint a portrait of an alien world's birth. Is this awakening a cosmic coincidence or a signal flaring to life? Hold fast. The Thor's secrets unfold. As 3I Atlas races toward perihelion in October 2025, its awakening becomes a cosmic eruption. At 1.4 astronomical units, solar heat turns its nucleus into a cauldron, vaporizing ices at an exponential rate. The coma swells, a glowing cloud larger than planets, while a faint tail begins to form, pushed by solar wind into a shimmering arc. This isn't just a comet. It's a time machine, shedding material forged billions of years ago under an alien star. Spectroscopes catch water, methane, and organics streaming outward, each molecule a clue to a distant system's chemistry. The process is chaotic yet structured, with jets bursting from specific zones as the nucleus spins, revealing a complex interior of rock and ice. Such activity should have faded in the interstellar void, yet 3I Atlas performs like a staged show. Loeb's speculation lingers. Is this a natural thaw, or a crafted display meant for our eyes? The sheer volume of material, tons lost hourly, suggests a robust core built to endure. As telescopes track its transformation, the question grows. Is this a random relic awakening, or a beacon activated by our sun? Imagine a telescope piercing the cosmic veil, capturing a frozen snapshot of an alien world in motion. When the Hubble Space Telescope turned its unblinking eye on 3I Atlas in July 2025, it revealed details that ground-based scopes could only dream of. This interstellar comet, a city-sized giant racing at 36 miles per second, emerged in stunning clarity. A teardrop of light, its nucleus glowing within a vast coma of gas and dust. Where Earth's telescope saw a fuzzy blur, Hubble unveiled a cosmic spectacle, streams of material bursting outward like frozen fireworks. The nucleus, a mile-wide core of ice and rock, pulsed with activity, hinting at a structure forged in an alien star's embrace. These images, the sharpest ever of an interstellar object, showed jets erupting from specific zones, marking areas where solar heat cracked open ancient ices. This wasn't just a comet, it was a living relic, shedding its skin for our eyes. But why such vivid detail? Is it nature's display, or something crafted to be seen? Harvard's Avi Loeb whispers, could these features suggest more than ice? Brace yourselves. Hubble's vision reveals the cosmic truth. Hubble's images of 3I Atlas are a cosmic gallery, each frame a masterpiece of alien architecture. The telescope's lenses caught a nucleus wrapped in a coma, stretching thousands of miles, its asymmetrical shape pointing away from the sun. A battle between solar radiation and the comet's feeble gravity. Bright jets sprayed from its surface like geysers on an icy moon, revealing a complex interior of layered ice and rock. These fountains, shifting as the nucleus spins, suggest a rugged terrain, scarred yet resilient after eons in the void. Unlike Oumuamua's silent surface, 3I Atlas is a performer, its outbursts visible even to amateur scopes. Hubble's data pinned the core at 1 to 3 miles wide, massive enough to shield alien chemistry, water, organics, and carbon compounds from cosmic rays. But the clarity raises questions. Why is this structure so well preserved, so photogenic? Loeb's theory lingers. Could these jets be engineered, a signal activated by our sun? Scientists counter with natural sublimation, yet the precision of Hubble's view feels almost staged. Each detail is a clue to an alien star's story. Hold fast. The cosmic canvas sharpens. Hubble's gaze transforms 3I Atlas into a cosmic fossil. Its details a window to another star's past. The telescope's images, sharper than any before, capture a nucleus alive with activity. Jets of gas and dust spiraling outward, painting a portrait of a world awakening. The coma's teardrop shape, stretching wider than Earth, reveals a dynamic core, spinning every few hours, each rotation exposing new zones of sublimation. These features, etched in light, show a structure built to endure, a mix of ice, rock, and organics, shielded from interstellar erosion. Hubble's measurements confirm a massive core, its size explaining how it survived millions of years. But the vividness nags. Why does it display such intricate patterns, as if posing for our lenses? Loeb's speculation stirs. Could this be a crafted object, its jets a deliberate flare? Mainstream science sees a natural comet, its outbursts driven by solar heat. Yet, as perihelion nears in October 2025, Hubble's images offer a fleeting chance to decode this visitor before it fades. Is it a random relic, or a beacon meant to dazzle? Picture a cosmic veil trailing millions of miles, shimmering with secrets from an alien star. As 3I Atlas nears our sun, its tail unfurls, a magnificent stream of dust and gas, glowing like a celestial banner across the night sky. This isn't just a comet's flourish. It's a living record, each particle a page from a distant world's history. Solar wind, a torrent of charged particles from our sun, sculpts this tail, pushing gas and dust away from the nucleus into a radiant arc. Telescopes like Hubble catch its dual nature, a blue glow of ionized gases like carbon monoxide and a yellow sheen of sunlit dust. These colors mark materials forged billions of years ago, now freed by solar heat. The tail's length, stretching farther than Earth's diameter, reveals a nucleus shedding tons of ice and rock daily. Unlike Oumuamua's barren silence, 3I Atlas performs, its tail a cosmic diary of its birth system. But why such a vivid display? Is it nature's art or a signal meant to dazzle? Harvard's Avi Loeb ponders, could this tail be more than natural? Brace yourselves, the cosmic story glows. The tale of 3I Atlas is a cosmic fossil, written in real time across the void. As the comet spins, its nucleus, a city-sized core of ice and rock, releases streams of material, shaped by solar wind into a spiral pattern like a galactic sprinkler. Spectroscopes reveal a chemical treasure, water vapor, methane, and organic molecules, all preserved from an alien star's nursery. The blue glow signals ionized gases, while yellow dust grains, some as large as sand, hint at rocky layers within. This diversity tells of a chaotic birthplace, perhaps a planet-forming disk shattered by a supernova. The tail's structure maps time. Older particles, pushed farthest by solar pressure, contrast with fresh emissions near the nucleus. Each grain carries clues to conditions eons ago, surviving interstellar erosion. But its vividness puzzles astronomers. Why such a clear record? Loeb's theory stirs. Could this tail be a deliberate flare, broadcasting alien chemistry? Scientists see natural sublimation, yet the tail's scale, visible to small scopes, feels curated. Is it a random relic shedding or a crafted message? Hold fast. The dust's secrets shimmer. As 3I Atlas approaches perihelion in October 2025, its tail becomes a cosmic masterpiece, stretching millions of miles. Solar heat intensifies, vaporizing ices at a ferocious pace, creating a coma and tail that dwarf planets. Hubble's images show spirals and tendrils, driven by the nucleus spin, revealing a complex interior of ice, rock, and organics. Spectroscopic data uncovers carbon compounds and rare isotopes, suggesting a birth near a massive star's violent end. These particles, shielded by the comet's bulk, survived eons of cosmic rays, now scattering like breadcrumbs from an alien world. The tail's glow, visible to backyard astronomers, feels almost performative, as if meant to catch our eye. Loeb's speculation looms. Could this be a signal? Its chemistry a coded message? Mainstream science points to natural processes, but the tale's clarity and richness challenge easy answers. As it flares brighter, each dust grain is a clue to a distant star's story, lost unless we act fast. Is this a natural spectacle or a beacon from the cosmos? Imagine a cosmic daredevil racing toward a stellar furnace, its fate hanging in the balance. In October 2025, 3I Atlas reaches perihelion, its closest approach to our Sun at 1.4 astronomical units, 130 million miles from a star hot enough to vaporize rock. This interstellar comet, a giant forged in an alien system, faces its ultimate test. For millions of years, it slumbered in the frigid void, its ices locked in eternal cold. Now, solar heat assaults its nucleus, triggering a transformation both spectacular and perilous. The sun's radiation, a relentless barrage of energy, cracks open water and carbon ices, releasing torrents of gas and dust. The coma swells, larger than planets, while the tail stretches millions of miles, glowing in the night sky. But this isn't just beauty. It's a battle for survival. The intense heat could shatter the nucleus, scattering its secrets. Telescopes worldwide, from Hubble to backyard scopes, track this drama, capturing outbursts like cosmic explosions. Is this merely a comet's trial by fire, or something designed to endure? Harvard's Avi Loeb whispers, could it be built to withstand this inferno? Brace yourselves. The solar crucible ignites. At perihelion, 3I Atlas becomes a cosmic cauldron, its nucleus a battlefield of ice and fire. Solar radiation, packing the punch of billions of photons, slams into its core, vaporizing thousands of tons of material hourly. Jets erupt like geysers, hurling debris across thousands of miles, each outburst a geological catastrophe rivaling nuclear blasts. The coma balloons, a glowing shroud dwarfing Earth, while the tail, sculpted by solar wind, blazes with blue and yellow hues. This frenzy reveals a robust structure, a 1 to 3 mile wide nucleus of ice, rock, and organics, built to survive eons. But the sun's fury tests its limits. Heat intense enough to melt metal threatens to tear it apart. Hubble's images catch these violent flares, showing a spinning core spewing spiral patterns. Why does it hold together? Loeb's theory stirs. Could this resilience suggest artificial design, a probe meant to shine at its peak? Scientists argue it's nature's endurance, yet the scale of activity feels almost staged. Each jet carries alien chemistry, a fleeting gift before the comet flees. Is this a natural struggle or a deliberate spectacle? Hold fast. The solar storm rages. As 3I Atlas braves the solar furnace, it's a race against annihilation. At 1.4 astronomical units, the sun's heat turns its nucleus into a pressure cooker, expelling gas and dust at ferocious rates. The tail, now a cosmic river millions of miles long, dazzles observers, visible to small telescopes. But each outburst risks fracturing the comet, scattering its alien secrets into the void. Its size, up to 12 miles across, offers hope, a core strong enough to endure this inferno, preserving ices from another star. Spectroscopes catch water, methane, and organics, a chemical legacy of a distant system. Yet, the intensity puzzles astronomers. Why such a dramatic show? Loeb's speculation looms. Could this be a crafted object, its outbursts a signal meant for us? Mainstream science sees a comet pushed to its limits, but the timing, peaking in October 2025, feels curated for our gaze. This fleeting moment, before solar glare hides it, is our last chance to decode its makeup. If it survives, it escapes forever. If it shatters, we lose a cosmic archive. Is this nature's gamble or a beacon's final flare? Imagine rewinding a cosmic tape, tracing a comet's path across millions of years through the galaxy's wilderness. The journey of 3I Atlas, hurtling at 36 miles per second, is an epic odyssey from an alien star to our sun. Supercomputers at NASA and ESA play cosmic archaeologists, modeling its trajectory backward through the Milky Way's chaos. Starting from Sagittarius, near the galaxy's dense core, it likely launched from a stellar nursery 4 to 7 million years ago, when Earth's first complex life was forming. This wasn't a gentle drift. Its blistering speed points to a violent birth, perhaps a supernova's blast or a gravitational slingshot from a massive planet. Threading through countless stars, it dodged disruptions that could have shattered it. Its ices, water, carbon compounds, organics, survived the void's brutal cold and radiation, locked in a nucleus up to 12 miles wide. This resilience raises questions. How did it endure such a gauntlet? Harvard's Avi Loeb muses. Could it be a probe built to survive? The math suggests a precise path, almost too perfect. Is this a random traveler or a messenger sent our way? Brace yourselves. The cosmic origins unfold. The survival of 3I Atlas is a cosmic miracle, a testament to its strength against the galaxy's harshest trials. Interstellar space is a desert of near absolute zero, where cosmic rays bombard like relentless sandstorms and dust grains strike like bullets at 130,000 miles per hour. For millions of years, this comet endured, its nucleus shielding alien ices from erosion. Backward models point to a chaotic origin, perhaps a red dwarf's flare or a binary star's tug flung it free. Its velocity, a galactic signature, suggests a recent launch in cosmic terms, crossing light years in mere millions of years. Yet, its path avoided stellar traps that could have deflected or destroyed it. The nucleus size, 1 to 3 miles wide, acted like armor, preserving water and organics that now flare under our sun. Loeb's bold theory whispers, could such durability be engineered? A craft meant to reach us? Scientists counter with natural resilience, but the journey's precision, threading past our planets, feels almost guided. Each molecule streaming from its tail is a relic of an alien world's birth. Is this a fluke of survival or a deliberate voyage? Hold fast, the cosmic saga deepens. The epic journey of 3I Atlas is written in its velocity and scars, a biography of survival across the stars. Its 58-kilometer-per-second sprint, tracked by global observatories, maps a path from a turbulent stellar nursery, perhaps near a supernova or colliding stars. This comet, a city-sized giant, survived eons of cosmic radiation that should have cooked its ices into dust. Its core, layered with rock and organics, held fast, now erupting in jets as it nears perihelion in October 2025. Tracing its origin demands precision. A 1-inch error could misplace its source by light years. Yet, models align on a launch millions of years ago, when our ancestors were microbes. Loeb's speculation looms. Could this be a probe? Its path and durability crafted to deliver a message. Mainstream science sees a natural survivor, but the journey's clarity, reaching us at humanity's technological peak, sparks doubt. As it sheds alien material visible to small scopes, it offers a fleeting chance to decode its story. Will it escape intact or shatter under solar fire? Is it a cosmic accident or a signal from the stars? As 3I Atlas races back into the void, it leaves us gazing upward, humbled by its journey. This interstellar wanderer, a relic from an alien star, crossed millions of years to brush our skies, carrying secrets of cosmic birth and survival. Its blazing tail and ancient ices remind us we are not alone in the universe's vastness. Each molecule, each jet, whispers of worlds we may never touch. Is it a random comet or a beacon sent to stir our curiosity? The question lingers, unanswered, urging us to look beyond our tiny world. Brace yourselves. The cosmos calls us to wonder.